Robotics is the field that studies how robots are designed, built, programmed, and used. It combines mechanical engineering, electronics, computer science, and control. Robotics aims to create machines that can sense, decide, and act in the physical world. The students tested their new walking robot in the robotics laboratory. Teams build autonomous machines and solve time challenges in the robotics competition. The robotics industry produces automated machines for factories, hospitals, and homes. A robot is a programmable machine that performs physical tasks automatically or under human control. It uses sensors to gather information and actuators to move or affect its surroundings. A robot may follow fixed instructions or make decisions from data. The robot arm lifted each metal part and placed it on the conveyor belt. The robot vacuum moved around the living room and cleaned the floor by itself. An industrial robot performed the same welding task hundreds of times in the factory. An actuator is a device that converts energy into physical motion. In a robot, it moves parts such as joints, wheels, or grippers. Actuators may use electricity, air pressure, or hydraulic fluid to create force. The linear actuator pushed the platform forward in a straight line. The rotary actuator turned the robot's joint through 90 degrees. The pneumatic actuator used compressed air to open the heavy gate. A sensor is a device that detects a physical condition and converts it into a usable signal. Sensors provide robots with information about themselves and their surroundings. Different sensors can measure light, distance, temperature, pressure, or motion. The motion sensor turned on the hallway light when someone walked past. The pressure sensor warned the operator when the air tank became too full. The proximity sensor stopped the robot before it touched the wall. A servo is a controlled mechanism that moves to and holds a requested position. It uses feedback to compare its actual motion with the command it receives. Servos are used when accurate control of angle, speed, or force is needed. The servo motor rotated the camera precisely toward the moving ball. The servo drive supplied power and adjusted the motor's speed from the control signal. The servo controller corrected the arm whenever it moved away from the target angle. A gripper is a tool that allows a robot to grasp and release objects. It is usually attached to the end of a robotic arm or manipulator. A gripper may use fingers, suction, magnets, or soft materials to hold an item. The robotic gripper picked up the fragile cup without crushing it. The vacuum gripper used suction cups to lift a smooth sheet of glass. The two jaws of the parallel gripper moved toward each other to hold the block. A manipulator is an articulated robotic structure used to move or position objects. It normally consists of connected links and joints that create controlled motion. The end of the manipulator can carry a gripper, tool, camera, or other device. The robotic manipulator moved electronic parts from one tray to another. The mobile manipulator drove to the shelf and then used its arm to collect a box. The scientist used a remote manipulator to handle radioactive material from a safe room. An encoder is a device that measures motion or position and converts it into signals. It is often attached to a motor shaft or robot joint to track movement. An encoder can report relative changes or an exact position within its range. The rotary encoder counted each turn of the wheel to measure how far the robot traveled. The optical encoder read light and dark marks on a disc to detect movement. After the power returned, the absolute encoder still reported the joint's exact angle. A controller is a device or program that coordinates how a robot operates. It receives sensor data, processes instructions, and sends commands to actuators. The controller manages timing, feedback, and safety while the robot performs a task. The robot controller read the sensors and ordered the arm to stop at the correct position. The motion controller synchronized 3 motors so the platform moved smoothly. She pressed a button on the game controller to make the character jump. Kinematics is the study of motion without considering the forces that cause it. In robotics, it describes the relationship between joint movement and the position of a robot's parts. Kinematics helps engineers calculate where a robot can reach and how it should move. Using the known joint angles, forward kinematics calculated the location of the robot's hand. Inverse kinematics found the joint angles needed to place the gripper over the box. The engineer studied robot kinematics to understand how the arms, links, and joints produced movement. Dynamics is the study of motion together with the forces and torques that produce it. Robot dynamics examines how mass, inertia, gravity, and contact affect movement. Dynamic models help engineers predict the force needed for a robot to accelerate or stop. Robot dynamics showed how much motor torque the loaded arm needed to rise. Rigid body dynamics treated the metal link as a solid object that did not bend while moving. Fluid dynamics helped the engineer predict how water would flow around the underwater robot. A trajectory is the path that an object or robot follows over time. It specifies changing positions and may also include speed, direction, and acceleration. A robot controller follows a trajectory to produce smooth and purposeful motion. The robot trajectory carried the gripper around the obstacle and down to the package. Engineers adjusted the rocket's flight trajectory so it would enter the correct orbit. Trajectory planning created a safe path before the robotic arm began to move. Calibration is the process of checking and adjusting a device so its measurements are correct. It usually compares the device's output with a trusted reference value. Calibration reduces systematic errors and improves the accuracy of robotic systems. Robot calibration corrected the arm so its gripper reached the coordinates in the program. During sensor calibration, the technician compared the temperature reading with a trusted thermometer. Camera calibration allowed the robot to convert image points into accurate real-world positions. Locomotion is the ability or act of moving from one place to another. Robots achieve locomotion with wheels, legs, tracks, fins, wings, or other mechanisms. The best form of locomotion depends on the surface, environment, and task. Robot locomotion on the rocky ground required flexible legs instead of small wheels. Bipedal locomotion allows a humanoid robot to walk upright on two legs. Scientists study animal locomotion to learn how birds fly, fish swim, and insects crawl. Navigation is the process of determining a position and choosing a route to a destination. A robot navigates by combining maps, sensor data, and movement estimates. Good navigation allows a robot to avoid obstacles and reach its goals safely. Robot navigation guided the delivery machine through the hallway without hitting people. Satellite navigation used signals from orbiting satellites to show the driver the car's location. Indoor navigation helped visitors find the correct room when satellite signals were unavailable. Autonomy is the ability of a robot or system to operate without continuous human commands. An autonomous system can perceive conditions, make decisions, and carry out actions by itself. Levels of autonomy vary from limited assistance to fully independent operation. Greater robot autonomy allowed the rover to choose its own route when communication was delayed. Vehicle autonomy enabled the car to steer, brake, and change lanes with little driver input. Personal autonomy means that an adult can make important choices about his or her own life. Perception is the process of interpreting sensor data to understand the surrounding world. Robot perception can identify objects, estimate distance, and recognize motion or people. It turns raw signals into useful information for planning and action. Robot perception helped the warehouse machine distinguish a box from a person. Depth perception allowed the robot to judge that the nearer block was 30 centimeters away. Visual perception lets people recognize shapes, colors, and movement through sight. Odometry is the process of estimating how a robot's position changes as it moves. It often uses wheel rotation, visual images, or motion sensor data. Because small measurement errors accumulate, odometry estimates can drift over time. Wheel odometry counted the wheel turns to estimate how far the rover had traveled. Visual odometry compared consecutive camera images to calculate the drone's movement. LiDAR odometry matched successive laser scans to estimate the robot's new position. Teleoperation is the control of a robot or machine by a human from a distance. The operator's commands are transmitted to the machine, while video or sensor feedback is returned. Teleoperation is useful when a task is dangerous, distant, or too complex for full autonomy. Robot teleoperation allowed the bomb technician to control the machine from behind a protective wall. Through remote teleoperation, a doctor in one city guided a medical robot in another city. Bilateral teleoperation sent the operator's hand motions to the robot and returned force sensations to the operator. Mechatronics is an interdisciplinary field that integrates mechanical, electronic, control, and software engineering. It focuses on designing intelligent machines whose physical parts and digital controls work together. Robotics is a major application of mechatronics because robots combine mechanisms, sensors, actuators, and computers. In mechatronics engineering, Students learn to build machines that combine motors, circuits, and software. The automatic door is a mechatronic system because its sensor, controller, and motor operate together. Students tested their sensor-controlled vehicle in the mechatronics laboratory.